In the end, I want to briefly mention some other ambiguity models. I already told you that in biology they have this term adaptive radiation. The field of ambiguity theory is quite in that stage. So there are many models, some are a bit weird maybe, and we have to converge and compete and take the good parts of all the models together to get good ambiguity models in the future. That's work to be done also by the listeners of this recording. I hope that they can contribute there. Anyway, I told you the class of multiple priors, and several examples I mentioned, but there are quite some other models here. I list a few. Variation is the variational models, and I mentioned a few, but here are other variational models, so more of that exists also. Then there is a model that deviates quite from all the others. It's quite a different animal, so to say. Vector expected utility by Siniscalchi. It's a really pretty model, pretty axiomatizations, but I think it's not empirically realistic. It cannot accommodate the fourfold pattern of ambiguity, for instance. So in that sense, but it's thought-provoking, so to say. Another two-stage model, that model by Good and Pesendorf, I'm going to discuss a bit more in a moment. Then in 2017, here a model. In 2017, I stopped updating. I think you're getting the picture by now. There's much more still, and many models, and much convergence is still to be done. I want to discuss a bit more the models by Gu and Pesendorfer, because they are closest to what we did in the literature. They are closest to the source method and to ring dependence. They published a paper 2014 in Econometrica. They had a model that maybe was a bit too general. Also, it allowed ambiguity attitudes to depend on outcomes. Already told you that homeomorphic is, I think it's not really very nice to have that. In 2015, they published a really remarkable follow-up paper in Journal of Economic Theory. They added an axiom to the original model that rules out dependence of ambiguity attitude on outcomes. Then they got a model that has many positive, many interesting properties. It is in fact a special case of the source method. You know, it's close to the thing that I do, so of course I like it. Some points of difference as well. First, I should say they have a preference foundation that's very efficient, very pretty. Few axioms very efficiently have big implications. That is really well done, but they have a price to pay for it. What they do what mathematicians call non-constructive concepts they use. They have something that they call diffuse events. Those are non-constructive. That means by the common axioms of mathematics, people do accept that they exist, but nobody will ever be able to write a formula or give a definition of these things, what they really are. So I could call it very unobservable. So in an empirical theory, I think it's not nice to have it. So Good and Pesendorf assume that these events are available, that you can even gamble on them. And so that's a bit, I guess they could, their model could be developed without, but that would be desirable to do. They also assume sort of extreme insensitivity with respect to these events, which I would find both empirically and normatively hard to imagine that could be the case. Then one last difference is they use the terms risk and ambiguity quite differently than I've done in this course. So those are, but still they have much in common. They do not use the Anscombe-Ammann framework, so they need not invoke these two-stage stimuli, which is desirable to avoid because they are complex and controversial. Importantly, they need not assume expected utility for risk. And if you want to do empirical work, you have to be able to do that. They have an integrated procedure for both risk and uncertainty. So that's quite like we did in this course with the source method and with prospect theory. And that's also, I think, desirable, that the risk and uncertainty, ambiguity are not different things, but risk is a sort of special case. So that's another point we have in common. Then most theoretical models papers do not consider this likelihood insensitivity, but the data imposed upon us. We have to develop models for it. In Gül and Pesendorfer, they do mention it. They do refer to it, the phenomenon. Although they don't integrate it very much into their model yet, they give a place to it, which also one wants to have done for empirical work. And then, of course, they are using source functions, which is like what we also do, and I think is efficient. So they have much in common. Well, many more theories, but I stopped updating after 2017. And then I want to show you applications of ambiguity models. And I made a list in 2018, And the rule of the game was I only use the application where the family name of the first author starts with an A. And then I made here a list, and I thought that was long enough. And of course, I assume you get the message. Ambiguity theories are used and applied in many domains, are relevant in many domains. And surely many of the listeners here can use it and put it to good use in whatever your field of application is. So I hope, I come now to the end of this recording. And I hope that the listeners can do many useful things in the future with the things they learned from these recordings. And so this is the end.